Hello and welcome back. These will be the notes for 5.5 parallel and perpendicular lines. There is a PDF available, so if you'd like to print it out and follow along, go ahead. First thing we'll look at is what are parallel and perpendicular lines. First is parallel lines, two non-vertical lines in the same plane. They have to be in the same plane that have the same slope. They have to have the same slope, but a different y-intercept. Example, there would be y equals 2/3 x plus 7 and y equals 2/3 x minus 3. These are parallel lines because they have the same slope, but their y-intercepts are different. Perpendicular lines, two non-vertical lines in the same plane again, same plane, that have, and this is important, negative reciprocal slopes, and they have to intersect at 90 degrees. Of course, the negative reciprocal slopes is what caused them to intersect at 90 degrees. Notice how it's kind of silent on the y-intercepts. We don't really care what the y-intercepts are. They can be the same, they could be not the same. What's important is that they have negative reciprocal for slopes. Two examples there. Y equals negative 2/5 x plus 7 is 1, and y equals 5/2 x plus 3. So if you look at the slopes are negative reciprocals of each other, and that's what makes them perpendicular. So important things up here are M and B. That's what makes them parallel. And important down here is M. M needs to be a negative reciprocal. Example 1, write an equation of a line that passes through the point -3 and -5 and is parallel to the line y equals 3x. Parallel means my slope has to be the same. Since this slope is 3, I need to have a slope of 3. The only thing that's missing is my b value. In order to find my b value, I have to use my slope-intercept equation. Y equals mx plus b. My slope is 3. My x and my y, I can choose to be -3, -5. And I'm just solving for the b value. So -9, -5 plus b. Add 9 to both sides, b equals 4. So there's my equation, y equals 3x plus 4. This is the line that's parallel to this one, but at the same time goes to that point. And that's how we write parallel lines. Example 2, write an equation of a line that passes through the point 4, 3 and is perpendicular to the line y equals 4x minus 7. So I need to find my slope. That's going to be easy. It's going to be the negative reciprocal of this slope. So the reciprocal will be 1/4, and then change the sign means -1/4. Now they are telling me that it has to go through a specific point. So even though I don't really care what the b value is, in this case I need to make sure that the b value is appropriate to go through the point 4, 3. So I'm still going to have to use my y equals mx plus b format to solve for the b value. So my slope is -1/4, my x value is 4, my y value is 3, and I can just solve backwards for my b value, my y-intercept. So 3 is going to equal -1 plus b. B then is going to equal a +4. And now I just need to write my equation. Y equals -1/4 x plus 4. And this ends up being the line that is perpendicular to this line, but at the same time goes through the point 4, 3. Example number 3. Determine which lines are parallel or perpendicular, and possibly neither. So we've got 3 lines here. I'm going to identify the slope of this first one. Slope is 5, and the y-intercept is -3. So I want to find out what the slope and the y-intercept of the next 2 lines are. Well, the slope of this line here, this is in standard form, the slope of the line is going to be opposite of the a value over the b value. So the opposite of a over b is going to be negative 1 over 5. And the y-intercept is going to be the c value over b, so 2 over 5. That way I don't have to rewrite the entire equation. Same thing over here. My slope is going to be opposite of a over b, so the opposite of negative 2 is 2, over negative 10 is 2/10, which I can simplify to be, well, it's actually negative 10, which I can simplify to be negative 1/5. And my y-intercept, that should be a b value. My y-intercept is going to be 0. So let's start with parallel lines. Parallel lines have same slope. So if I look at the line A, B, and C, I see that line B and line C have the same slope, but they also have to have a different intercepts. So look at their intercepts, 2/5 and 0, and those are definitely different. So line B is parallel to line C, and the symbol in the middle there stands for parallel. To be perpendicular, we are looking for negative reciprocals. So perpendicular is negative reciprocal. Negative reciprocal slopes. So I have a 5 here, so the negative reciprocal, that would be negative 1/5, which I can clearly see I have 1 and 2 lines. So I don't really care what the y-intercept is on perpendicular lines as long as their slopes are negative reciprocals. So we could say that line A is perpendicular to line B, and line A is perpendicular to line C. So B and C are parallel to each other, and line A is perpendicular to both. Last example, parallel and perpendicular lines. Does the path of the puck from the form a right angle? So the puck is here, it's traveling along this path, and we want to know, is it a right angle? In other words, are the two lines intersecting at 90 degrees? That would make them perpendicular. If they were perpendicular, then they would have negative reciprocals for slope. So rather than writing the entire equation, all I really got to do is calculate the slope of this line and the slope of this line and compare them to see if they're negative reciprocals of each other. So let's go ahead and calculate the slope of the first one. Be 16 minus 8. So the slope of the first one here will be 16 minus 8, which is 8 over negative 4 minus 0 is negative 4, so that's a slope of negative 2. And the second one is 8 minus 0, which is 8, and 0 minus negative 4, which is 4, and that gives us a slope of 2. Yes, they are negatives of each other, but they are not negative reciprocals. So these lines are not perpendicular to each other. So will they form a right angle? The answer is no, they will not form a right angle.